control technologies for nitrogen oxide, we have prevention. Prevention is the process that employs the fact that reduction of the peak flame temperature in the combustion zone reduces nitrogen oxide formation. Routine burner tune-ups in operation with combustion zone temperature at least values prevents the increase of fuel utilization and nitrogen oxide formation. Next, we have post-combustion capture. Post-combustion capture refers to the removal of carbon dioxide from power station flue gas prior to its compression. Transportation and storage in suitable geological formations as part of carbon capture and storage. There are three processes that may be used to convert nitrogen oxide to nitrogen gas. It is selective catalytic reduction or SCR, selective non-catalytic reduction or SNCR, and non-selective catalytic reduction or NSCR. Selective catalytic reduction or SCR is a process of selectively reducing harmful nitrogen oxides to nitrogen across a catalyst. Selective non-catalytic reduction or SNCR, on the other hand, is a post-combustion emission control technology for reducing nitrogen oxide by injecting an ammonia-type reactant into a furnace at a properly determined location without the need of a catalyst. The last one is non-selective catalytic reduction or NSCR. It is an add-on nitrogen oxide control technology for exhaust streams with low oxygen content. Non-selective catalytic reduction uses a catalyst reaction to simultaneously reduce nitrogen oxide, carbon oxide, and hydrocarbons to water, carbon dioxide, and nitrogen. The catalyst is usually a noble metal. Second to the last subtopic is particulate pollutants. It is the suspended microscopic solids and liquids particles present in the form of droplets floating in the atmosphere. There are devices that are used to control particulate pollutant production. First that we have here is a cyclone. Cyclone or cyclone separators are separation devices that use the principle of inertia to remove particulate pollutants from flue gases. In the cyclone separator, dirty flue gas is fed into a chamber. The inside of the chamber creates a spiral vortex, similar to a tornado. The lighter components of this gas have less inertia, so it is easier for them to be influenced by the vortex and travel up it.
When high-efficiency control of particles smaller than 5 micrometer is desired, a filter may be selected as the control method. The fundamental mechanisms of collection by filters include screening or sieving because the particles are larger than the openings between the fibers, interception by the fibers themselves, and electrostatic attraction because of the difference in static charge on the particle and fiber. There are two types of filters. First is the deep bed filter, and second, the baghouse.
The first type of filter is a deep bed filter. A deep bed filter is effective for relatively clean gases and low volumes, such as air conditioning systems. The deep bed filter resembles a furnace filter. A packing of fibers is used to intercept particles in the gas stream. Another type of filter is the baghouse filter. It is usually used by stationary sources with dirty industrial gas with high volumes to control emissions of air pollutions. Liquid scrubbing. Liquid scrubbing can be an alternative if the particulate matters are too hot and cannot be processed using the filters. Typical scrubbing applications include control of emissions of talc dust, phosphoric acid, foundry cupola dust, and open-earth steel furnace fumes. There are three energy usage levels for wet scrubbers. First is low energy wet scrubber, second, medium energy scrubber, and high energy scrubber. Liquid scrubber 3 energy levels. First is a low energy wet scrubber. It utilizes pressure drops less than 5 inches of water column and are capable of efficiently removing particles greater than about 5 to 10 micrometers in diameter. Second is a medium energy scrubber. It has a pressure drop from 5 to 25 inches of water column and is capable of removing micrometer-sized particles, but is not very efficient on sub-micrometer particles. Last is a high-energy scrubber. It expands the most energy and has a pressure drop of 25 to 100 inches of water column, which is necessary to remove sub-micrometer particles. Electrostatic precipitator, or ESP. It is a device which removes dust or other finely divided particles from a gas by charging the particles inductively with an electric field and then attracting them to highly charged collector plates. Underneath is an example of an electrostatic precipitator diagram. The last subtopic that we are going to talk about is the control technologies for mercury. There are two broad approaches being developed to control mercury emissions. First is powdered activated carbon injection and enhancement of existing control devices. Powdered activated carbon absorbs the mercury from the combustion flue gas and is subsequently captured along with the fly ash in the particulate control device. It is injected downstream of the power plant's air heater and upstream of the particulate control device. Second is the enhancement of existing control devices. There are existing control devices to eliminate or lessen mercury emissions, like the flue gas desulfurization unit or a selective catalytic reduction, or SCR, and enhancing them could be the answer to the excessive mercury emissions in stationary sources.